Greetings to you all. Today we are going to look at measures of location and central tendency and the statistics. Okay, so when we talk about measures of location and central tendency, we mean three things. That is mean, mode, and median. And so normally we call them 3Ms. Okay, so with each of them we are going to look at its population and sample, population and sample. Then mode 2 we will do same. Mean 2 we are going to do same for that sample. Okay, so whenever you hear measures of location and central tendency, just have it in mind we have three things, that is mean, mode, and median. Okay, so here let's look at mean first. So mean, let's look at mean. Okay, so with mean we have three ways of calculating for mean. That is, we have arithmetic mean, we have coded mean, and we also have assumed mean. Okay, but here any format or any formula that you use, you are still going to get the same answer, because they are all methods of what calculating for mean. So here the focus will be on arithmetic mean, and with arithmetic mean we will also talk about the population and the sample. So let's dive into arithmetic mean. Arithmetic mean. So arithmetic spelled this way. Yeah, arithmetic mean. Okay, so arithmetic mean, as I said, we have population and sample. So when we talk about population is just about the entire data. So if you have 1, 2, 3, 4, and you are being asked to calculate population mean of this data, it means you have to add everything here and you divide it by the number of appearances or observation. So here we have what? 1, we have 2, we have 3, we have 4. So population mean will be 1 plus 2 plus 3 plus 4. Then you divide it by 1, 2, 3, 4. So 4. Now 1 plus 2 is 3, plus 3 is 6, plus this one is 10. So you have 10 over 4. You can also say 5 on 2, or 2 number 1 over 2. You can equally say 2.5. Anyway, okay, so this is how to calculate the population mean. And when we talk about the sample, you have to take 1 from the denominator. So here let's take a question and deal with it. So population mean. Okay, so population mean, I said that talks about what? The entire data. So example, you have 2, 7, 6, 5, 4, 3. Let me just take these two out. Yes, so you have 2, 7, 6, 5. Now the first question is, or the question is, calculate population mean. Population mean. Okay, so if you want to calculate population mean of this data, it is what? 2 plus 7 plus 6 plus 5. How many number of observations? That is 1, 2, 3, 4. So you divide it by 4. So if you add this to this, it's 9 plus this one will give you what? 15 plus this one 20. So you have 20 over 4. Now the final answer is what? 5. It means the population mean of this data is what? 5. When you hear mean means average, and so it means averagely this number, the these four numbers or this observation, if you want to find the average or the mean, the answer is what? 5. That is for population. So just have it in mind whenever you are calculating for population mean, you just sum the entire data and you divide it by the number of appearances or the number of occurrences. That is it. Then the next one is the sample mean, because now we know the population mean. You just sum everything and you divide it by the number of occurrences or appearances. Okay, so let me just clean this one. Sample mean. Sample mean. Okay, sample mean. So sample mean, you know, population talks about the entire data, and when you say sample is just some portion of what? The entire data. Do you get it? So it means if you have this data and you try to take anything from this data, it becomes what? Sample. So if you have 2, 5, 7, if you take this 7 out, now the remaining becomes what? Sample, because initially we had what? 7. We have 2, 5, 7. That is 3 occurrences. 3. Now we have reduced it by what? 1. So remaining what? 2 occurrences. It means these 2, the 2 and 5 here is what? The 2 and 5 here is what? The sample. Sample. It means you have taken some portion of the entire population. Okay, so let's look at how it also works. How it also works. So for sample, the formula for calculating sample mean is sigma fx over, okay, this one is group data. We are talking about on group data. So sigma x over n. Okay, so this sigma x over n means summation of all the data given, then you divide it by the frequency or the number of occurrences. Okay, so with this one example, if you have 2, 5, 7, 1, 2, 5, 7, 1, let's say 5. Okay, so if you are being asked to calculate sample mean of this data, you know this is what? Population. So it means sample is going to be some part of this data, right? You know there is the formula for calculating what? Population mean. Sample mean is what? -1. Do you get it? So it means you have to take some portion of this population. Do you get it? So this is how it becomes. Sigma x means sum everything here. That is 2 plus 5 plus 7 plus 1 plus 5. Then you divide it by 1, 2, 3, 4, 5. So you have 5 minus 1. So this is how sample mean looks like. So with population mean, you only sum the total number, then you divide it by the number of occurrences. Do you get it? That's what we did over here. But for here, you sum everything, you divide it by the total number, and you deduct 1 from it. Do you get it? So here 2 plus 5 is what? 7. Plus 7 is what? 14. Plus 1 is 15. Plus 5 is 20. So you have 20 over what? 4. Because 5 minus 1 is what? 4. Now 20 divided by 20 divided by 4 is what? 5. Right? So the sample mean for this particular data is what? 5. Do you get it? So just have it in mind. Anytime you are calculating for sample mean, anything sample, just take 1 from the denominator or the frequency. But when you are calculating for population, always the number of observation or the occurrences will be the denominator, and you sum everything here. Do you get it? You know, this is what in our previous video we realized if you have such data, it is what on good or raw data. So something like this is what raw data. And so when you are dealing with raw data, there is absence of what f. Do you get it? Which is the frequency. So just have it in mind. Anytime you have this, you just sum it without looking for any frequency. You divide it by 1, 2, 3, 4. That is the number of occurrences or observation. So that is about the arithmetic mean. But this is what on good data. You will get to good data where you realize a data will be given. Sorry, a table will be given, and we use that table to construct. We use that table to construct our own items, and also use the same table to find for mean, median, and mode. Okay, so we are done with the arithmetic mean. Let's also talk about one aspect of this mean. One aspect, that is, we have let me use this side for geometric mean. Geometric mean. Okay, geometric mean. For geometric mean, a raw data will be given. So anytime a raw data is given, we have a formula for calculating geometric mean. This one deals with formula, and you have to keep the formula in mind. Do you get it? This is not about procedures or methods. So this one talks about what? A formula. So just keep the formula in mind. When we are dealing with geometric mean, we have nth root of, you multiply any observations you have, xn. Okay, this means any data given, if you have the x values 2, 3, 5, they are all what? X, x, x. Do you get it? Yes. So you just multiply everything here. Do you get it? So if you have 3 numbers, 2 times 3 times 5, right? That will be under the square root. And the n here, this n here, it represents the number of occurrence. So if you have 3 numbers, 4 numbers, it will just appear here. So since we have 3 numbers here, 3 will just appear here, and we multiply everything here. Do you get it? So that is geometric mean. Now let's try to solve a question under geometric mean. So for example, if you have 2, 1, let's say 3, and so you solve it, your roots. Now you ask yourself, what is n? You count these numbers. That is 1, 2, 3. So it means n is what? 3, right? Then we are saying all these numbers are what? X values, right? So you multiply them under this root. So first one is what? 2 times 1 times what? 3. So here we say we have 3, then this side we have 2 times 1 is what? 2 times 3 is what? 6. So we have cubic root of 6. We have cubic root of 6. So cubic root of 6, we have 1.81 2 times 1 times 3, 1.817. We have 1.817. 1.817. So that is the geometric. So that is it. This is geometric mean. So always have it in mind that when you are calculating for geometric mean, it does with what? A formula. That is nth root of first x multiplying second x times till you get to the last x. That is it. So example like this, we have 2 and 3. How many number of observations? That is 1, 2, 3. So we have 3. You count them and you bring the number here. So right after that, you try to multiply all the x values under the square root. So 2 times 1 times 3. Then when you finish, you multiply everything. You can do it straightforward, or you can still simplify what you have here, and you finalize on your answer. That is this one. Okay, so that is geometric mean. And under this geometric mean, we have application of geometric mean. We have application of geometric mean. So application of geometric mean, this one also deals with what? Formula. So this one too, you also need to go by a formula, which is nth root of ending value over beginning value minus 1. The minus 1 is not under the square root, so have it in mind. We still have this n here, and this n in the question most of the times talks about the number of years or the range. Do you get it? And the ending value talks about the value you have in the question at the end of a certain period, and the beginning value to same. So all these parameters will be provided in the question. When you finish inputting them in your formula, then you deduct it from what? 1. That is it. Okay, so let's pick an example, and we are saying if you earn 30,000 a year in 1990, right? So in 1990 you earn what? 30,000. Okay, and 50,000 in 2000. So 2000 you earn 50,000. Okay, what is your annual rate of increase over the period? So here we are looking for the what? The percentage what? Increase over the period. 1990 you are earning 30,000. 2000, in 2000 you are earning what? 50,000 Ghana cedis, right? Yes. So what is the percentage increase? That is what the application of the geometric mean that we are talking about. So here we are saying the nth root talks about what? The range or the interval of a certain period. So here from 1990 to 2000, that is how many years? So you can just do a simple calculation. 2000 minus 1990, you have what? 0, you have 1, you have 0, 0. So probably you have what? 10. So from 1990 to 2000 is how many years? 10 years. So n is equal to what? 10. Do you get it? Then the two of these two cedis, which one is the beginning value and which one is the ending value? This is the beginning, because initially the person was earning what? 30,000. So this is the beginning value, and the ending value is what? 50,000, because at the end of the period, which is 2000, the person is earning what? 50,000. And so the beginning value is this one, and the ending value is also this. So we have all the parameters. Let's insert our data into the formula and solve for it. So n is what? 10. So we have 10 root of ending value is what? 50,000 over beginning value is 30,000. Then we subtract it from 1. Okay, so we solve for it. The 10 is not down here. The 10 is, it is 10th roots. Do you get it? So you don't put the 10 here. Okay, so 10 50,000 over 30,000 will give us minus 1, will give us 0.052. Yes, so this is the increase. This is the annual rate increase from what? 1990 to 2000. So if you want to find the percentage, you just multiply this by what? 100. Do you get it? So if you multiply this one by 100, this is what? Just an increase, right? So if you want to get to the actual percentage, you just multiply this by 100. That is 0.052 times 100. So 100 means 2 decimal place. So the point is now here. So you have 5.2%. So the increase is what? 5.2%. Okay. So this is application of geometric mean. Just have it in mind. You have your formula which says ending value over beginning value, all minus what? 1. Do you get it? Then from the question, you look for n. Sometimes n will be given to you in the question, and also you just have to put it in mind that if you are given 2 years, you have to find for the range or the interval. That one becomes what? The n. Then you look for the beginning the beginning value and the ending value. You subtract everything from 1. Then that will be your annual rate of increase. Okay. Then let's also look at weighted mean. Okay, so now let's look at weighted mean. When we say weighted mean, we are interested in the number of, let's say in a given organization or firm, we have number of employees. So averagely, if they are to share a certain salary released by the manager in the organization, how much is everyone going to get? Let's put whether this person is a director or manager, let's put all these things aside. If they are to share it equally, how much is everyone going to get? Don't forget, initially I told you mean is about what? Average. It means on a normal basis, how much is everyone supposed to get? So let's pick an example using the formula for weighted mean. So the formula here is W1x1 plus W2x2 plus W3x3 till you get to the last number. When you finish, you add all the weights. That is W1 plus W2 plus W3. So here, this W1 that you see is what? The weight. And this X that you see is the average. They'll give you the average salary in the question. And so with the average salary, it's just like you see something like per hour or average. Sometimes you see the mean salary of these particular employees, right? So just keep it in mind, they are all what? XXX. And the W normally talks about what? The number of employees in the organization, or sometimes too you see they normally say weights, right? We normally call them weights. Okay, so let's pick a question. We are saying the quality construction company pays its hourly employees 6,500. So 6,500 and 7,500, 8,500 per hour. They are saying what? Per hour. So anything related to per hour, it is what? Average or mean, and that is what? X, right? So all these are what? X. Then they are saying there are 26 hourly employees. So the 26 here is what? The weight. And so we have W. They are saying 14 are paid at the 6,500. So this 6,500, we have 14 employees who are receiving 6,500. And we also have 10 employees who are receiving 7,500. And we have 2 employees who are receiving 8,500. So this is what we have. We have the weights, we have what? The X or the average, right? So now we are going to find the total salary, and we spread the total salary by the number of employees in the particular organization or firm. That is all about the weighted mean. So now let's calculate the weighted mean using the formula, right? We know W is here, X is here. So the first one is what? 14 times 6,500. That is the first one. This times this plus. Now the next one is W2 times X2. So W2 is 10 times the X2 is what? 7,500 plus the next one is what? W3. Here is supposed to be N. Yes, and we also have WN. Okay. So the next one is W3. That is what we have here. That is 2 times 8,500. That is X3. So we say 8,500. We are stopping here because when you see this WN, XN, they represent the last number, right? So here the last number is what? The third one. Even if we have another fourth one, that one will be W4, X4. Do you get it? So we divide it by the width, W1 plus W2. So W1 is 14 plus W2 is 10 plus W3 is what? 2. So this is what we have. So we are going to multiply this, and multiply this. Now when we multiply this, 14 times 6,500, we have 91,000. So we have 91,000 plus. Now 10 times 7,500 is what? 75,000 plus 2 times 8,500 will also give you 17,000. Then you divide everything by 14 plus 10 is what? 24 plus 2 is what? 26, right? So you have 26 here. Now you add everything here because you see the plus, so we sum everything here. 91,000 plus 75,000 plus 17,000. That is 183,000. That is 183,000 divided by what? 26. So this 183,000 is the total what? Salary that is supposed to be shared to 26 employees. Now we don't care whether this person is a manager or this person is a director. We want to share this 183,000 to these 26 employees. So the answer that you get, that answer is what? A salary for one person in the organization. So let's spread the salary by the number of employees in the organization divided by what's 26. We have 738.46. 7,038.46. Yes. So this is what we have. Let's say Ghana cedis, Ghana cedis, Ghana cedis. So it means now if you are to interpret this answer, it means this 7,038.46, that is what? That is an hourly salary for one employee in the organization. That is what we mean by weighted average or weighted mean. So let's take another example and look at it using the same formula. So just have it in mind. You have W1 X1, W2 X2, like that. You multiply them, you divide it by your width, right? So let's take another question and do it. Okay, so the next question. In a company having 80 employees, how many employees do we have now? That is 80. 60 and $10 per hour. So now you see we have 60 who are earning what? $10 per hour. I said when you hear per hour, it means what? X. That is the mean, right? And this one becomes the width. Okay. And 20 and 13 per hour. So 20 will come here. The per hour will go to X. 20. Determine the mean earning per hour. So it means the average earning per hour, all the employees in the organization, the average salary for all of them. Let's calculate for that using the same formula. So W1 X1, this one times this one. So we have 60 times what? 10 plus we have 20 times 20. Then we divide everything by 60 plus 20 because W plus W. So 60 plus 20. Now here will give you 600 plus, this will give you 400, right? Is it? No, they are saying this 20. Okay, yeah. So this will give you 400. 400 divided by what? 80, right? Okay, so 600 plus 400 will give you 1000 divided by 80. So 1000 divided by 80, what are we getting? We are getting $12.5. So it means in the organization, averagely one employee earn what? $12.5. That is how we calculate what? Weighted mean or average. Always you multiply your weights by your mean. When you finish, you divide everything by the summation of the number of weights you have. You find for the average. That is all. So we are done for the weighted mean. Let's now move on to median and mode. Median and mode. Okay, mode. So mode, we are interested in that particular number with highest what? Frequency. So in any given data, don't forget we are talking about raw data, right? So if you have 2, 1, 3, 5, 1, 1, 6, this is a raw data. And when you are being asked to calculate for the modal number or to look for the modal number, here you are to look for that particular number with what? Highest number of occurrences or observation or the highest frequency. So when you look at 2 is only 1. If you look at 1, 1, 2, 3, right? And obviously 1 is the number with the highest what? Appearances in this given data. So we can say here, our modal number is what? 1. Do you get it? So that is it. Mode is about scanning through the data or observing the data, then you just pick the number with the highest frequency. Another example, if you have 6, 5, 2, 2, 6, 1, 6, 2, 3. Okay, let me add another 2. Okay, so this one, if you are to look for the number with the highest appearance, 6, you see we have 1, 2, 3, right? 5 is only 1. If you look at 2, we have 1, 2, 3, 4. And 2 is the number with the highest frequency. So that one becomes our mode. That is 2. And so this is how we calculate for mode. Mode is just simple. You just read through, you scan through the data, and you pick the number with the highest number of observations. So now let's look at median. Median. So for median 2, we are interested in the number that is located in the middle of a particular data because we are saying central tendency. Okay, so now we are going to look at group data, and with group data too, we are going to look at how to calculate mean from a grouped data that has been grouped into classes, and we'll do same for mode and also median. Now let's first look at mean. Now the formula for calculating mean of a group data is, that is sigma fx over sigma f, right? So this talks about what? The summation, right? And this x is what? Midpoint. In our previous video, you know, x is what? The midpoint, and f is what? The frequency. And so now always have it in mind, whenever you have a formula and you want to do a calculation, what you do is you start from the right to left. So with this formula, you start from this right hand side and you move towards what? Left. Do you get it? And if only you remember the formula, everything is going to be okay, because the formula will tell you what to do. Now the formula is telling you to find x because you don't have x from the table. So if you are starting from your right hand side, you have to calculate x, right? Then you do next, that is for what? F. You move towards summation. So now let us calculate for what? X. Okay, so with x, we know x is what? The midpoint. X is the midpoint. And so how do you calculate the midpoint? Now we know we calculate the midpoint by adding the two class limits and divide it by what? 2. That is the midpoint. Okay, so now 5 plus 9 will give us what? 14. And we divide this 14 by what? 2 to get what? 7, right? So we have 7. 5 plus 9 is 14, divided by 2 is what? 7. Okay, now the next one is 10 plus what? 14, which is 24. Now 24 divided by 2 is what? 12. Don't forget, in our previous video I told you, if you get the first midpoint and you want to save time, what you do is you find the difference between this, right? So the difference between this is what? 5. Or the difference between this is what? 5. It means you have to add the 5 throughout. Do you get it? So now the difference between 9 and 14 is what? 5. And your first number is what? 7. So now you add 5 to 7 to get what? 12, right? You add 5 to the 12 to get what? 17. You add 5 to the 17 to get what? 22. You also add 5 to this 22 to get what? 27. So this one will help you to save time, other than adding, dividing by 2, adding, dividing by 2. So always, after getting the first midpoint, find for the difference and add it so you get to the last class. So you have the x. You ask yourself, the formula is saying x, right? So we have calculated for x. Now this x here is multiplying what? F. Can you see that? This x here is multiplying f. So it means we have to create a column by multiplying this x by what? F, right? Okay, so I would like to clean this for more space, this one as well, since we all know we are calculating for mean. Okay, so now the fx, that, let me write the formula here so that you don't forget. Mean is equal to sigma fx over f, and so the fx that you see is what is here, because we have our x and our f. Okay, so now what we are going to do is we are going to multiply each frequency by what? The midpoint. So 20 by 7 will give us what? 140. Now 43 by 12 will give us 516. 75 by 17 will also give us what? 1275. 67 times 22 will also give us 1474. 72 times 27 is 1944. Okay, so now we have the fx. This is the fx. We first did for x, now have multiplied it by what? The f. Now what is next? Summation, right? So it means we have to sum the fx, right? So we have to sum everything here. Now 1444 plus 1474 plus 1275 plus 516 plus 140. So we have, so here too we say sigma fx is equal to 5349. So that is it. So we are done with the first part. The second part is what? Sigma f. That is what? Summation of the f. Frequency is the f. So the summation of f is here, but we don't have the number. So let's add everything here. We have 20 plus 43 plus 75 plus 67 plus 72. So we have 277. Now we can calculate our mean. Since we have the top one, which is sigma f x, then we have the sigma f. So now we can say our mean is equal to 5,349 over 277. So our mean is equal to 5,349 divided by 277. We have what? 19.31. And so this is our mean. For mean, if any method that you use, you will still get what? The same answer. So this is what? Arithmetic mean. If you use coded mean, you get the same answer. If you use assumed mean, you get the same answer. And so now, as I said, the focus will be on what? Arithmetic mean, since they will all give us the same answer. And please, with this one too, you can use the calculator to calculate for the mean. Please, you can go to our channel menu and you will also find that video there. Okay, so the next one to do is what? The mode. The mode. So now we are done with calculating what? Mean of a group data. We are done. So now let's look at how to calculate for mode. Okay. Let me clean this. And now write the final answer here so that you don't forget. 19.31. Okay. So let's now look for, let's say, mode of any group data. Now this one also has a formula which says for you to calculate mode, your lower class boundary of the modal class plus you have change 1 over change 1 plus change 2 multiplying C, right? Or this, it is the same, that's the class interval. So change 1 here over change 1 plus change 2. This L is the lower class boundary of the modal class. Now we always say we start from the right, so the class interval, we have the class intervals here, right? Okay, change 1 means what? This change 1 means the frequency of the modal class. So the frequency of the modal class minus the frequency of the preceding class, the frequency of the preceding or its preceding class, right? Okay, change 2 is frequency of the modal class minus frequency of the succeeding class. Okay, and L is what? Lower class boundary of the modal class. Lower class boundary of the modal class. Okay, so that is it. C, as I said, is what? The class interval. Class interval. Now you ask yourself, before you even start with your calculation, you have to know the modal class, right? And you ask yourself, which of the classes here is the modal class? First, you check the frequency. So which class has the highest frequency? We have 75 here, and 75 here has what? The highest frequency. It means this particular class is our modal class. This is our modal class. Do you get it? So we are going to use everything here in our calculation. And since we know our modal class, we are saying change 1 is the frequency of the modal class minus the preceding, and change 2 is the frequency of the modal class minus the succeeding. And L is what? The lower class boundary of the modal class But with this class, we don't have the class boundaries, right? So we have to calculate the class boundaries in addition. Okay. So class boundaries. So with class boundaries, you know already, we said it is what? The difference between the diagonals divided by 2. So there is the diagonal, right? So the difference between the two divided by 2. So that is what? I need a place. That is 10 minus what? 9, right? So we have 10 minus 9 divided by 2. 1 over 2, which is 0 0.5. So the boundary is what? 0 0.5. Now you subtract 0 0.5 from here, you add it to this side. Okay, so you subtract 0 0.5 from here, you get 4.5 to 9.5. And this now 9.5 will descend 9.5 to 14.5. And so you have 14.5 here to 19.5. 19.5 to 24.5. And this one too, same, you subtract 0 0.5 from it, so you have 24.5 to 29.5. Okay, so we are done with the class boundaries. So now can we move on to our mode, since we have all the parameters? Okay, so now let me clean the formula. Sorry, let me clean the explanation so that we look at the formula and solve the question. So the L, which is what? The lower class boundary of the modal class. We know this is our modal class, right? So now this is our modal class. The lower class boundary is what? This one, right? Yes, because these are the class boundaries for the class, and this is the lower class boundary. So we say 14.5 plus, now change 1. We said change 1 is the frequency of the modal class minus the preceding, the one that comes before the modal class. So 75 is the frequency of the modal class. So you have 75 minus the preceding is what? 43. So this is the change 1 divided by the same change 1. 75 minus 43 plus change 2. We said change 2 is what? The delta 2 or change 2 is what? 75 minus what? 67, right? So we have 75 minus 67. Yes, that is it. That is what? Delta 2. Okay, so let's also look at the median, how to calculate median of a group data. We are done with the mode. And so for the median, the formula is L plus 1 over 2n minus CF, that is cumulative frequency, right? All over F, that is the frequency, times the C, that is the class size or the class width, right? So we say cumulative frequency of all the classes preceding the median class, right? Yes. And L is what? The lower class boundary of the median class. F is the frequency, and C here is what? The class size or the class width, right? Okay. Now you ask yourself, this black or the dark line here represents the modal class. We use that one for the modal class. So let me just clean this one, and we now look for the median class, right? So before you look for the median class, this is the median class, that is half n, right? It means half times the total frequency, because we want the number that is located in the middle of the observation, right? And our total frequency is what? 277. Our total frequency is 277. So half times 277. So 1 over 2 times 277 is what? 138.5. 138.5. So this 138.5, you have to cumulate all the frequencies, so you get what? 138.5. And because you also have cumulative frequency here, it is always advisable that you calculate for what? Cumulative frequency as well, because you still need the cumulative frequency, and that cumulative frequency will also help you locate the 138.5 easily, right? So here we know our median class is what? 138.5. And 138.5, I'm going to clean this one so that we get a space for the cumulative frequency. So don't forget our median is 138.5. Okay, so now cumulative frequency cumulative frequency So the cumulative frequency, the first one we have 20, so we have 20 here. We will add this 43 to the 20 to get what? 63, right? This is 75, so we add 75 to the 63. We add 75 to 63. We have 138. We have 138. 138. And we add 67. We add 67 to it. We have 205. And we add 72. 72. We have 277. Okay. So now our median was 138.5. So we are looking for the median class is the median class, it can be located in the cumulative frequency by 138.5. Okay, so 138.5. Now let's look through the cumulative frequency. We have 138, but we have 0.5, so it means 138.5 is located within this class. Do you get it? So 138.5 is not located here, but rather what? Here. So it means we can classify this class as our median class. So always have it in mind before you start with the median class or the median. First of all, you have to calculate your half n. Do you get it? Or sometimes you see n over 2. It is the same. 1 times n is n, so n over 2. It is the same. So you calculate half n first. N is the total frequency, right? So half 277. The number that you get, which is the 138.5, this number, you have to search for this number from the cumulative frequency table, where you see or where that number will fall. That particular class becomes the median class. So it means you are going to use all the parameters here for your calculation. Do you get it? So now we know the formula already. Let's start. The L represents what? The lower class boundary of the median class. So we have L, which is 19.5. So we have 19.5 plus, we have 19.5. Let me just move it this way a little bit. 19.5 plus our n over 2 or half n. We have already calculated for it, which is 138.5. So we write 138.5. That is it. You are not going to change the number. You use the same number minus the cumulative frequency preceding this class, right? So this is the median class. So the cumulative frequency, you can either cumulate all the frequencies here. So if you cumulate all the frequencies here, the answer is this, right? So the cumulative frequency preceding the median class is this. You don't cumulate the cumulative frequency again. It is not cumulative frequency, but rather what? cumulative frequency preceding what? This class. So you cumulate all the frequencies preceding what? This class. And if you cumulate 1, 2, 3, you get this one. That is 138. So 138 over, now, over frequency of the median class. That is F, right? Don't forget, our formula was L plus N over 2 minus cumulative frequency over frequency times what? C, right? And so now frequency of the median class is what? 67, right? Is 67. Then you multiply it by what? The class interval or the class size. Now the class interval or the class size is what? The difference between the class boundaries or the vertical difference, of which we have here 5, right? So we multiply it by 5. Okay. Now we put everything on the calculator to calculate for our median. That is 19.5 plus 138.5 minus 138 divided by 67, right? 67. Sorry, 19.5 plus 138.5 minus 138 divided by 67. Then all multiplied by 5, right? So times 5. We have 19.54. We have 19.54. 19.54. This is it. Okay. Yes. So this is the end of the class. But this 19.54, because we don't have, in our next question, we just solve a proper question, examinable question. This is just an example. So join us in the next class as we solve questions about good data and non-good data. So then for this one, sometimes you can just run it depending on the question to get what? 20. Do you get it? But sometimes you maintain it. That is why I said because of the table, that is why we are getting 19.54. But in most cases you get 20 and above. Yes. But join us in our next class as we solve more examinable questions. So please kindly subscribe to the channel, like, and if you have any problem too, you make sure you put it at the comment section. We will just come and help you. All right, thank you.